Hi, welcome back to the Introduction to Python Programming. This is section 12, data control. And in this lesson, we have a few concepts to go over that deal with accessing and writing out data. So let's get started. So the lesson objectives for this video include understanding encoding, decoding, regular expressions, reading and writing files, API access, and that last bullet is of course the commit related to our lab environment, and we'll pull the resources related to this lesson. So identify encoding type. So in the first column, we can see table 12-1 encodings. What is encoding? Well, it's a set of rules that a program or a computer follows to decipher text characters. And some of them are similar enough that most of the characters would be the same. But if you use that wrong encoding when it was really the other encoding type, you probably would start to get strange characters in your data, which could cause errors, the incorrect output, the incorrect thing to happen. So UTF-8 is probably the most common, followed by ASCII. If you use the wrong method to decode, you may get errors or seemingly random characters. And that's a big sign that you're using the wrong encoding or decoding type, is that you're seeing random characters in your output. So assumptions are made. Many libraries and Python assume you are using UTF-8. Some may detect the encoding type for you. If you're unsure, verify by printing the results. So if you have a file that you're working with that some client or company is sending you and you're unsure what encoding type that they are using, you may read that file in the Python language and then print out the results and make sure everything looks good to you. The other thing would be, and that's in the next column, if you're working with a client, ask what the encoding type will be. If querying a data source, check the documentation. A lot of times this information is readily available to you. You just need to ask or check the documentation, which helps eliminate any need to try and guess your way through what type they're using, because that does get annoying pretty fast. But let's take an example. Let's take a look at an example. So we have an encode example. On line 1, we open the file test.txt with a encoding type of Windows-1258. And on line 6, we open the same file with an encoding type of UTF-8. So if we look at the output that we print from the file, we can see that the first print prints out the cow jumped over the moon. However, the beginning has very strange characters in front of it. And then the second time that we read the file and print it out, we have the sentence that we expect: the cow jumped over the moon. So the first encoding type was able to get a lot of the characters correct, but it obviously had an error because it introduced a lot of random characters. And the second one was correct. The file was written for UTF-8, so that's why that file doesn't produce any strange characters. So when you're working with encoding or decoding, and a lot of times in my experience, I don't even have to mess with this. I can just read the file, use the file, and I don't have any issues with the encoding type. But every now and then, I'll start to get strange characters, and I'm like, okay, I need to look at what type of encoding I'm doing. And I either have to use the right encoding type or I have to convert the file to the right encoding type. So that's what you'll want to be on the lookout when you're dealing with these types of problems. Are you getting strange characters in your files or in your output? All right, let's go ahead and move on to the next thing. Regular expressions. So we use regular expressions to match patterns for those extra difficult scenarios. Now, an easy scenario that we might all be able to imagine is, let's say you have a user base that's making comments within an application you provide. Let's say they're writing reviews for products, or they're talking to each other, and you want to make sure that they're not saying any bad words. Well, you might write a regular expression to find those bad words. In another example, you might want to make sure that no one talks about their credit card or social security number. You might write a regular expression to find that data and replace it with empty space if someone types it, or replace it with the words, hey, no social security numbers, whatever it is that you're trying to do. So in Python, we have the RE module, which provides a lot of out-of-the-box functionality so that you do not necessarily have to write regular expressions, but you do want to become familiar with regular expressions, because at the end of the day, when you need to find those complex patterns, you can't avoid having to use a regular expression. You're going to have to use one. For example, if you want to find that social security number, there's no RE dot find social security number. You're going to have to write the regular expression to find that number. So RE methods in the middle column RE must be a class then, right? Yep, RE is a class. We import that class, and then we use the class methods that are provided. We didn't have to write any of this ourselves. Somebody else took care of that for us, and we're using their code to just more or less get to the problem we want to fix. So that's a list of some of the class methods and their uses. Of course, just Google RE documentation, and there's a whole big document that describes everything the class does. And then custom expressions. Regular expressions, or regex, is a syntactical language for finding patterns. It is a very powerful feature and is supported in most languages. It is deserving of its own course. So we're just going to touch on these concepts in here. We're not going to do a deep dive in regex, because regex can take a long time to go through and understand how everything is working. But a lot of times, if you're looking for a common pattern, for example, credit card numbers, you can just say, you can go to a search engine and type in Python regex credit card number, and it'll give you the regex you need to use for that. And then, of course, if you're interested in exactly what's occurring, you go to the regex documentation and look at what the different characters mean. And usually, a lot of times, it's pretty straightforward. For example, you see that D4. I'm pretty sure that's just indicating 4 digits. All right. So in the example screenshot, we can see, sure, my credit card is blah, blah, blah. And then we can see that when we run this example, it'll find that credit card number in the note. And we'll see what that prints out in the lab. All right, let's move on to the next thing. Reading and parsing files. So we did see the files get open in the previous screenshots, but now we're going to kind of discuss that more closely. So we use the open method to read files. And you can see that on line 8, we open the test.txt file. It's the file or file path. Because it's in the same directory, there's no path there. It's just the file name. But if it was in a different directory, we would need to put the path to the file so that the Python engine could find it. And then reading. The R indicates reading. When we open the file in this way, we cannot write to the file because we've told the program we're going to read this file. We are not going to write to the file. And then at the top, we have a simple person object, a class definition. And then the read lines function. The open function returns an object that has a read lines method. This method creates a list of lines from the file that we can iterate over. Okay. So the data object, notice that no variable declaration occurs. The data object itself is placed in the list. So we have an employees.append, which is using the employees list that is created on line 9 to append the person object that gets created. And the person object is a reference to the class that occurs on line 1. So we have a first, last, age, and that becomes a person with a first name, last name, and an age. And then because that list only has one person in it, there's only one line in the file that's employees at the 0 element, and we're printing out its age just to show that we were able to load that person into the list. Now this is actually pretty similar to a work assignment I once had where I had to parse a file sent by some HR software and load it into some ERP software. I had to read the file and identify employees and load all their data into the ERP system. And I had a very similar approach where I used the class to create that object, and then I output that object in a way that the loading system understood. Now, I didn't touch on this, but the file data that I was using for this example was only one line long, and it was John, Smith, 22. And you can see that on line 11, we did a line dot split, comma, so we split on the commas. John Smith 22 would have became a list of 3 items, where list item 1 was John, list item 2 was Smith, list item 3 was 22. All right, let's go to writing files. Writing data to a file. So very similar to reading a file. Pretty easy and straightforward thanks to those objects that we can already use, like the open object. It doesn't get much easier than that. So the file is open with the W code, which indicates writing. The write function. Again, the open function returns an object with a write method. Use this to write to files. And you can see that on line 19, we're writing a string with string interpolation where we embed variables into that string to a file. And then here is where we first touch on closing files. When you're done working with files, you want to close them. And you want to close them related to the operation that they were responsible for. For example, on line 16, we closed the file because we had opened the file on line 8 as a reading operation. And then we wanted to open the same file, or no, actually a different file with a write option. And then on line 21, we closed that file that we had open with the write operation. So you definitely want to close your files to avoid errors. It is possible that you open a file and never close it and don't have an error. But if you accidentally open the same file twice, you could start to have errors, which could be the program crashing or putting random data in a file. And you definitely want to avoid that. All right, let's move on to APIs. Accessing API data. API keys or header authorization for secure access. So there's two main ways that people access APIs with a secure layer, and that's usually with either an API key, which you pass in the URL, or header authorization, which is a username and password combination. Now, Polygon.io has a free account option. You should make your own account for this lesson. The Polygon.io documentation indicates that you only can access their data 5 times in a minute. So if you try this too many times, like you're having some kind of an error, but you're accessing their API and you do that 5 times in the first 10 seconds, well, you're going to have to wait 50 seconds before you can try again. So that's something to keep in mind when you're attempting this. And of course, if everyone was to use the same key and you happen to be working on it when 50 other people are doing it as well, you guys might immediately exhaust that key. So you want to make your own key, your own account, use your own key to access this. So in the screenshot, we have a stock class used to control API access and data related to the type of API we're accessing, which is for stocks. Import request, this was installed in a previous lesson using pip3, so we needed that request library for easier API access. And a reference to the API key. The API key is a secure identifier. Typically, you do not save these in code. It would be the same as saving your username and password in code. But while you're learning and you're going through basic development, saving that in your code is perfectly fine, especially for free public accounts. You're not going to really expose anything that is really bad. But if you are working for a company where you're working with employees that have salary data, project data, or anything that might be confidential, you'll definitely want to be very careful on how you're storing that type of information. We're not going to go over that in this lesson for sure, but a lot of times they'll use like environmental files or something that's not even part of the version control. It's something file that every programmer has that belongs to them. Okay, so we close files. We close file when operation completes to avoid errors. Oh, that's actually a mistake. That's a reference to the old screenshot. Don't pay any attention to that. The other ones are good to go though. All right, let's jump into the lab environment and take a quick look. All right, here we are in the lab environment. You can see that I've already checked out the correct section. Now I did have to do a reset hard to get rid of my unintended changes I made in section 11, and then check out section 12, which was commit code FAC16E. Well, let's take a quick look at the cheat sheet and make sure it's the correct one. Section 12, data control cheat sheet. Okay, that's correct. Be sure to look through that, as it does have additional information that can sometimes help you when working on the questions. And let's go ahead and jump into the exercises. So section 12 questions. These were a little bit more involved. So task 1, getting the encoding correct on data is important for effective data analytic and manipulation. If you are approaching a new data source and encounter strange characters in output, what steps can you take to remedy the situation? Okay, so no coding there, just asking you how you would go about fixing that problem. And then task 2, regular expressions are used to find patterns in data. Identify the regular expression for finding social security numbers. Test it in a Python program. Use a search engine to identify the pattern. Don't waste time trying to figure out regex semantics. So I want you to just get the pattern as quickly as you can and use it and test it using a search engine to find it. If you try to dive into regular expression documentation, read it through and understand it fully, well, I might not see you for a week or two. So we just want to dive in, extract what we can, and it may not be perfect. We expect that, but we just want to get an idea of how we might approach that problem in a way that more quickly addresses the item we want to solve. And then task 3, create a Polygon.io account and use the provided API key to pull down stock data. Any data will do. Write the data to a file. So you're just going to go to the Polygon.io website, create an account, use the API key they provide you, pull down any data, and write any of that data to the file, and that task will be considered a success. Okay, so go ahead and take some time to solve those tasks. Pause the video if you need to, and we are going to go over the answers in 3, 2, 1. Here we go. All right, actually, let me leave those open just in case I need to reference them. Answers, section 12 answers. Okay, so task 1 answer. First, check the documentation on the data source in case it's mentioned there. There's a good chance the documentation might just say, hey, we encode our data in this way. You need to decode it in such a way. Next, ask the data source provider directly. Perhaps you're working with a client that's giving you the file. Just ask them what the data encoding is if you have any questions. Lastly, run the common decoding types and see if the special characters disappear that you're noticing in the output. And task 2 answer. So you can see that we can identify this and test it in 7 lines of Python code. Not too bad. So we import the RE library, and then we do an re.search, and then that's the regular expression I found for social security numbers. Hopefully you got something similar. It doesn't have to be the exact same regular expression. You do sometimes find different versions of them that account for different things. For example, I believe mine accounts for a social security number not starting with 3 zeros. Okay, and task 3 answer. This is pretty similar to the slide that we saw in the course, right? So this is a 20-line file, not too bad at all. We have that stock class that was shown in the slideshow. And anytime you see those items in the slideshow, feel free to copy them out and use them for yourself while you're updating your answer to answer the task. So you can see that the, what's the complicated thing here? So the complicated thing here is the stock class. We initialize that with the URL that we need to access. APIs are commonly accessed over URLs. And I'm using a default example that they provided in their documentation, and I'm providing a key that the user or the programmer passes in as part of the initialization of the stock object. And then the get data method just returns a get of that URL and casts it to JSON so that it's easier to read. So then on line 16, we say stock get data, and we get the dictionary entry of tickers, because when we bring back that JSON, it's actually a Python dictionary that comes back, and it's a dictionary that contains other dictionaries. So we get back that tickers dictionary. We open the stock.txt with a write operation, and then we say for ticker and stock data. Then we write out a string interpolation of the ticker and a reference to the name and locale. Okay, and then that writes out, and that works just fine. So I hope you got that. Now you didn't have to get that answer exactly, but as long as you pulled down stock data and wrote it to a file, that would be acceptable. So I hope you were able to get that. Let me know in the comments if you had any trouble. Let's go ahead and head back to the course and close out the lesson. All right, here we are back at the lesson. We already went over this slide, so let's go to the section conclusion. In this lesson, we learned about encodes, decodes, regular expressions, reading and writing files, and API access. Now, in the next lesson, it's actually going to be a more lengthy work assignment. We're not actually going to go over any new concepts. We're going to combine the concepts that we've already went over to solve a problem that's closely related to a work problem I once had. And it should be a lot of fun solving this problem. And don't worry, I'll have a worksheet that basically gives all the details of what you need to do and what a good way to solve it would be. And then of course, I'll have the answer and we'll go over that too. So I hope you enjoyed this lesson. I hope to see you in the next. Have a great day.